Have you ever looked up at the night sky and wondered about its secrets? For thousands of years, humans have gazed at the stars. We saw them as fixed points of light in a vast, unchanging darkness. We imagined the universe as a giant static dome over our heads. But what if I told you that this picture is completely wrong? What if the universe is not still at all? Imagine a universe that is alive, dynamic, and constantly growing. Our quest to understand the universe is like a great detective story. For centuries, we were the detectives, staring at a crime scene with very few clues. Then, at the dawn of the 20th century, new clues started to emerge. We started to see that the faint, fuzzy patches of light we called nebulae were not just clouds of gas within our own Milky Way. To understand redshift, we first need to talk about light. But if you pass it through a prism, a magical thing happens. The light splits into a beautiful rainbow of colors. This is called a spectrum. Every element in the universe, like hydrogen or helium, has a unique light signature. These lines are like a fingerprint or a barcode for that element. Have you ever stood by the side of a road as an ambulance or a police car with its siren blaring speeds past you? As the ambulance approaches you, the pitch of the siren sounds higher. Then, as it passes you and moves away, the pitch suddenly drops and sounds lower. If a galaxy is moving towards us, it will compress the light waves it sends in our direction. Scientists call this a blue shift. When a galaxy is moving away from us, it stretches out the light waves. This is redshift. The cosmic detective story now moves to a mountaintop in California. Here, at the Mount Wilson Observatory, the world's most powerful telescope was pointed at the heavens, and the man looking through that telescope was an astronomer named Edwin Hubble. Hubble had a special trick up his sleeve, a new tool for measuring cosmic distances. He was looking for Cepheid variable stars. By finding these stars, he could calculate how far away the entire galaxy was. In 1929, Edwin Hubble was ready to present his findings. The result was breathtakingly simple and profoundly significant. The points did not form a random scatter. Instead, they fell along a straight line. The farther away a galaxy was from us, the faster it was moving away from us. Hubble's law points to a much stranger and more wonderful idea. The fabric of space itself is stretching. As light travels through space, the space it is traveling through is expanding. This expansion literally stretches the light waves, making them longer and redder. The idea that space itself is expanding can be tricky to visualize. So, let's use a famous analogy: a loaf of raisin bread dough. As the dough bakes, it expands and rises. From the perspective of any single raisin, all the other raisins appear to be moving away from it. A raisin that was originally 1 centimeter away might now be 2 centimeters away. The farther away a raisin is, the faster it appears to be moving away. Crucially, this model shows us that there is no center to the expansion. Every single raisin would see the exact same thing. The straight line on Edwin Hubble's graph did more than just prove the universe was expanding. Think of it as the universe's speedometer. The current accepted value is around 70 kilometers per second per megaparsec. This constant is the magic number that converts a measured redshift into a distance. If you know how fast something is expanding, you can run the clock backward to figure out when it started. With our modern precise measurements of the constant, this calculation gives us an age of about 13.8 billion years. The discovery of the expanding universe was more than just a new fact to add to the science textbooks. It was a complete and utter revolution in human thought. Edwin Hubble's discovery shattered this ancient and comforting picture forever. Suddenly, the universe was no longer a static stage. It had a story. It had a history. If all the galaxies are rushing away from each other now, then yesterday they must have been closer together. The universe was not an eternal, unchanging entity. It was a dynamic, evolving system that had a beginning and was actively changing with every passing moment. The logical consequence of an expanding universe is that there must have been a beginning. If you run the movie of cosmic expansion in reverse, eventually, you must reach a moment when everything was compressed into an unimaginably hot and dense state. This inevitable conclusion is the seed of the Big Bang theory. The Big Bang was not an explosion in space like a bomb going off. It was the explosion of space. The Big Bang theory made a bold prediction that a faint afterglow from this early hot phase should still be detectable today. In 1965, Two American radio astronomers, Arno Penzias and Robert Wilson, accidentally discovered this very radiation. This was the smoking gun for the Big Bang. Then, in the late 1990s, came another shocking discovery. By using distant supernovae as standard candles, astronomers found something completely unexpected. The expansion of the universe is not slowing down. It is speeding up. It is accelerating. To explain this cosmic acceleration, scientists have had to propose the existence of dark energy. Together, dark energy and dark matter make up about 95% of the cosmos. All the matter we can see makes up only a tiny 5% of reality. The journey that started with a simple shift in starlight has led us to a truly humbling conclusion. We have journeyed across billions of light years and billions of years into the past, all by following a single subtle clue: redshift. This simple shift in color was the thread that once pulled, unraveled our entire classical understanding of the cosmos. It revealed a universe in constant, magnificent motion, where the very fabric of space-time is stretching and growing with every passing second. The simple fact that starlight is redder than it ought to be has completely reshaped humanity's place in the cosmos. And by continuing to gaze upwards, to question and to explore, we continue to write our own small but significant part in this great unfolding cosmic story.